Hello everyone. Today we are going to discuss about least recently used approximation page replacement algorithms. These are of three kind: additional reference bits algorithm, second chance algorithm, and enhanced second chance algorithm. Earlier we have discussed about FIFO page replacement, optimal page replacement, and least recently used page replacement. This is the variation of the least recently used page replacement algorithm that is based on the approximation. So let's discuss these algorithms one by one. First one is additional reference bits algorithm. That means in this we uses a reference bit which is initialized at 0, and after a reference has been made to a particular frame, the hardware updates the reference bit from 0 to 1. We can use 8-bit byte as reference bits history to check out the history of the previous references that are made to particular frames. At regular intervals, we have to shift the reference bit into the high order bit of 8-bit byte simply by shifting the bits one by one to the right and discarding the low order bit. That means we have to shift the bits right one each, and we will discard the low order bit. Then it will be the reference bit in high order of 8-bit byte. We have to do this when a reference has been made to the particular frame, then its value will be changed to high order bit. This is the example for additional reference bits algorithm. Initially, if the 8-bit byte is 0000000, then no page has been referenced for 8 time period. If it is all ones, then it used at least once in each time period. That means the frame has been used every time for at least once. And if it is a random of combination of ones and zeros, then is more used more recently than this 0 1 1 1 0 1 1 1. Then next comes second chance algorithm. It uses FIFO and a reference bit along with it. It is implemented using a circular queue. It is also referred to as a clock algorithm. Now, what clock algorithm says? It requires the association of an additional bit with each frame. That means one additional bit will be attached to each frame when it is referenced, and this additional bit is referred to as the use bit. We call this additional bit as use bit when a page is first loaded in memory. That means a particular page is referenced by the system. The use bit is set to 1, that it has been referenced, and the set of frames is considered to be a circular buffer. The number of frames in the physical memory are organized into a circular buffer, and any frame with a use bit of 1 is passed over by the algorithm. That means any frame with having value 1 for the reference bit, for the use bit, will not be picked up as a victim frame. That means it will not be replaced by the desired page. For the replacement, the use bit value must be 0. Then Page frames are visualized as laid out in a circle into this algorithm. That's why we call it a clock algorithm also. You can see this in this diagram. In this, various pages are arranged in a circular queue. The upper diagram shows the state of the buffer just prior to a page replacement, before the replacement of a page. In the center is a pointer which points to the next frame to be referenced. In the lower diagram, it is the state of the buffer just after the next page replacement, and the pointer moves to the page 13 with the use bit value 0, and it will be replaced with the desired page. The next one is enhanced second chance algorithm. This is the algorithm which considers the reference bit and the modified bit as an ordered pair. Second chance algorithm is having only a reference bit. In the enhanced second chance algorithm, we are having pair of two bits. One is reference bit and another one is modify bit. So there are four possible cases in this. 00, that means neither recently used nor it is modified. We are talking about particular frame. If the particular frame has a value of 00 for the reference bit and modify bit, then it has neither recently used nor it is modified. If the value is 01, then it is recently used, it is recently not used, but it is modified. First bit is for reference bit and second one is for modify bit. If first one bit is 0, it means it is not recently used, but it is modified at least once. If the value is 10, so it means it is recently used but not modified. And if the value is 11, then it is recently used and also it is modified. Then another algorithm is counting based page replacement algorithm. As the name suggests, counting, that means it counts the number of replacements that are made to a particular frame, and on the basis of that the replacement happens in the system. And for counting, it uses a counter to count the number of references that have been made to each page. The total number of references that are made to a particular page are counted by a counter and are stored. And on the basis of that, we derive two sub algorithms of this. One is least frequently used and second one is most frequently used. Least frequently used says that if the counter value for a particular page or frame is very less, so it notifies that it is the least frequently used page. And if the counter value for a particular page is very high, then the system defines it as the most frequently used page. And the page that is most frequently used are put into the physical memory for a longer period of time so that lesser number of page faults occur because it is the most frequently used page, and least frequently used pages are put into the secondary storage when are not required. So this is about counting based page replacement algorithm. And last one is the page buffering algorithm. As you can see the name buffering, that means it uses a temporary storage, a buffer, to hold the frames. That means the frames that are required or that are used to store the pages that are required for execution by the process, that are that frames are stored or hold in a pool of the frames in a buffer. And when a page fault occurs, a victim is chosen, but the page is read into a free frame from the pool before the victim is written out. That means we have made a separate pool of frames, free frames, and that pool is used to hold the pages in between the replacement process. That means when we are required to replace a particular page, we just choose it but does not replace. हम उस पेज को चूज कर लेंगे फिजिकल मेमोरी में, लेकिन रिप्लेस नहीं करेंगे। रिप्लेस कब करेंगे? रिप्लेस तब करेंगे जब जो डिजायर्ड पेज है पहले उसको फेच करके हम कहाँ पे लेके आएंगे, वी विल पुट दैट पेज इनटू द पूल ऑफ द फ्री फ्रेम्स। और उस फ्री फ्रेम्स के अंदर से एक पर्टिकुलर फ्रेम के अंदर हम क्या कर लेंगे, उस पेज को लोड करेंगे, एंड देन we replace the victim frame out of the physical memory. That means replacement is done, but first desired page is loaded into the physical memory, into the pool of free frames, and then the page is replaced from the physical memory to the secondary storage. In this, when a page fault occurs, we first check whether the desired page is in the free frame pool. फर्स्ट हम ये चेक करेंगे कि जो डिजायर्ड पेज है वो फ्री फ्रेम्स का जो पूल है उसके अंदर अवेलेबल है या नहीं है। अगर नहीं है तो पहले क्या करेंगे, सेकेंडरी स्टोरेज से पेज को लोड करवा के फ्री फ्रेम पूल के अंदर क्या करेंगे, उसको लोड करवाएंगे एक फ्री फ्रेम के अंदर, एंड देन वी विल रिप्लेस दैट पेज फ्रॉम द फिजिकल स्टोरेज टू द secondary storage, and the desired page is already there in the pool of free frames, so the process will use that page for execution of the process. So this is all about the page replacement algorithms that we have discussed. I hope you like them and will understand the concepts very easily. With the examples we have done them. If you find any difficulty in any algorithm, then you can contact me on my WhatsApp or on my email. You know my contact details that are shown in the uh, presentations, in the slides of the start. That is the page replacement policy that we have studied about page replacement policy. In that video we have given the contact details also. Also I can convey you my contact number, that is 80592 If you feel any difficulty, any problem, then you can contact me at any time. Thank you very much. This is all about page replacement algorithms. Let's meet up with a new video with a new topic of discussion. Thank you very much.